These cheese slices look yummy.
Notice that they are triangular in shape.
Oh yes. Can I find out if these two slices are congruent?
Of course you can. But first, let's learn how to find out if two triangles are congruent.
Congruence of Triangles. Here are three triangles A, B, C, D, E, F and P, O, S. Let us see if they are congruent. Place the tracing paper over triangle A, B, C and trace the triangle. Now, place the tracing paper over triangle DEF. Therefore, we can conclude that triangle ABC is congruent with triangle DEF. Now, if we place the same tracing paper over triangle POS, we see that the triangles do not fit each other. Thus, we conclude that the triangle ABC is not congruent with triangle POS. Look at these two triangles. Triangle ABC is congruent with triangle DEF, and there is one-to-one correspondence between ABC and DEF. According to this correspondence, angle A is congruent with angle D. Angle B is congruent with angle E, and angle C is congruent with angle F. Similarly, side AB is congruent with side DE. Side BC is congruent with side EF, and side AC is congruent with side DF. Congruence of scalene triangles. Look at these two scalene triangles, LMN and PQR. Let's find out if these two triangles are congruent. Place a tracing paper over triangle LMN and trace the figure. Then place the traced triangle LMN over triangle PQR. Notice that the two triangles fit each other exactly. This shows that triangle LMN is congruent with triangle PQR. Let us now try to put the copied triangle LMN on PQR in another correspondence. Let's use the correspondence LMN to RPQ. We see that the two triangles do not fit each other. Thus, we conclude that triangles LMN and PQR are not congruent in the above correspondence. Let's try another correspondence, LMN to QRP. Again, in this correspondence, we see that the two triangles are not congruent. Similarly, if we try other correspondences apart from LMN to PQR, we will find that the triangles are not congruent. So, we can conclude that if two scalene triangles are congruent, they are congruent for only one correspondence. Congruence of isosceles triangles. Triangles XYZ and DEF are isosceles triangles. Triangle XYZ is congruent with triangle DEF. With a pair of scissors, cut out the triangle XYZ. And place it over triangle DEF. So, if we place vertex X on vertex D, vertex Y on vertex E, and vertex Z on vertex F, we see that the two triangles exactly fit each other. This means that there is one-to-one correspondence between XYZ and DEF. Therefore, triangle DEF is congruent with triangle XYZ. Let's now use the correspondence XYZ corresponds to DFE. We place the cutout of triangle XYZ on DEF in such a way that point X is placed on point D, point Y falls on point F, and point Z falls on point E. Notice that the two triangles fit each other. It means that triangles XYZ and DEF are congruent by this correspondence too. So, finally, we can conclude that if two isosceles triangles are congruent by one correspondence, they will be congruent by one other correspondence too. Congruence of equilateral triangles. Take a look at these two equilateral triangles MNS and GLO. Let's see if these two triangles are congruent. With a pair of scissors, cut out the triangle MNS. And place it over triangle GLO in a way such that points M and G coincide, points S and L coincide, and points N and O coincide. We see that the two triangles exactly fit each other. Therefore, triangle MNS is congruent with triangle GLO, and there is one-to-one correspondence between MSN and GLO. If we consider any other correspondences, we will find that triangle MNS is congruent with triangle GLO. Therefore, we can conclude that if two equilateral triangles are congruent in any one correspondence, they are congruent in every other correspondence. It's time for an activity. Triangles RST and FGH are congruent. There is one-to-one correspondence between R and F, S and H, and T and G. Write the pairs of the congruent sides and angles of the two triangles. According to the problem, triangle RST is congruent with triangle FGH. In the correspondence, RST corresponds to FHG. This gives us 3 pairs of congruent sides and 3 pairs of congruent angles. The following are the pairs of congruent sides. Side RS is congruent with side FH. Side ST is congruent with side HG, and side RT is congruent with side FG. The following are the pairs of congruent angles. Angle R is congruent with angle F. Angle S is congruent with angle H. And angle T is congruent with angle G. Here's another activity. In triangle PQR, side PQ and side PR are of the same length. In triangle XYZ, side XY and side XZ are of the same length. These two triangles are congruent. With the help of the given figures, identify and write the correspondences in which they are congruent. According to the problem, sides PQ and PR are equal. Therefore, triangle PQR is an isosceles triangle. Similarly, sides XY and XZ are equal. Therefore, triangle XYZ is also an isosceles triangle. Now, from the diagram, we see that side PQ is congruent with side XY. Side PR is congruent with side XZ, and side QR is congruent with side YZ. This means that triangle PQR is congruent with triangle XYZ, and there is one-to-one correspondence between PQR and XYZ. Since triangles PQR and XYZ are isosceles triangles, side PQ is congruent with side XZ. Side PR is congruent with side XY, and side QR is congruent with side YZ. Therefore, triangle PQR is congruent with triangle XYZ, and there is one-to-one correspondence between PQR and XZY.